Okay, homework tonight is 39 through 65 odd, section 2-3. So let's do a couple of each section so you know what you're doing. Are you ready? 39 through 44. The directions say verify the given factors of the function f. So letter B, how do I verify that those are factors? What are the factors? They give you factors being x plus 2 and x minus 1. How do I verify algebraically that those are factors?
Does it equal 0?
No. What are we doing? What have we learned this period, or this section? We've learned synthetic division. So if we learn synthetic division, wouldn't it make sense that we need to use synthetic division? So how do we prove that something is a factor using synthetic division? If the remainder is 0, then the thing is going to be a factor. Do we all understand that? Okay? So what this means is, I'm going to do synthetic division at the values what? What's my first value I'm going to do synthetic division at? -2. I solved x plus 2 for 0, and that gives me -2. I drop down my coefficients. That's 2, a 1, a -5, and a 2. How do I know that I was correct and I haven't missed any of my terms? 3, 2, 1, 0. I've shown that I've not missed anything. Honey, I'm doing your homework. This would be a wise idea for you to maybe copy it now. Your homework tonight is 39 through 65 odd. 39 through 65 odd out of the book. Now today, what I'm doing is not all of your problems for you. Some of them are going to be evens because you only have 2 from each section. If I do one of them, that leaves you only 1 left to do. And I need to make sure that you guys understand what you're doing. Does that make sense? So I'm going to do some of the evens and some of them, okay? All right, so we're going to go ahead and do synthetic division here. So I drop down to 2. 2 times -2 gives me -4, plus 1 gives me -3. Multiply on the diagonal gives me 6, minus 5 gives me 1. Multiply on the diagonal gives me -2. This gives me a 0. What does that 0 indicate again? That this is going to be a factor. I have proven that it is a factor because I got a remainder of 0. Now also, when I do synthetic division, it was degree 3. The first time I do synthetic division, what does it drop it down to? Degree 2. Now, watch this. If x plus 2 is a factor of that polynomial, I'm left with what polynomial? 2x squared minus 3x plus 1. Agree? But it's also telling you what else is a factor. It's telling you that also positive 1 is a factor, correct? So I'm going to go ahead and I'm going to do synthetic division at positive 1 for the remaining polynomial. I'm not going to start it from scratch. I'm going to go from what I just did synthetic division at. Because if one is a factor, does it matter which one I would have chosen to do first? No. So if one's a factor and the other one's a factor, I have to prove that. It doesn't matter which one I choose to do first. I can do synthetic division off the remaining polynomial. And I should still get a remainder of what? 0. Do we understand that? So if I do this, I pull down the 2. 2 times 1 gives me 2. Minus 3 is -1 times -1 gives 0. And what degree is this going to be now? It was degree 2. Now I did synthetic division, so now it makes it degree 1. Did I prove that those are factors? How did I prove that they were factors again? Because my remainder was 0 on both of them. Agree? Okay, so that's letter A. This is letter A right here. I verified. I used 2, -3, and 1. I used the red. Because that's what I talked about before. It didn't matter if I started synthetic division at the 1 or the -2. I chose to do -2 because that was the first one they gave me, correct? Could I have done synthetic division at the 1 first instead of the -2? Absolutely. It doesn't matter. They both are going to come out with a remainder of 0. Doesn't matter. What I did know is if x minus 1 is going to be a factor, it also has to be a factor of what the remaining synthetic division was.
Could you go with the actual problem to the one I thought?
Yes, it would have came out the same if I had done it with the original. But if I do it with the original, I'm not breaking it down further. See, the whole goal is just like you have a GCF, you want to pull out your GCF, right? I want to pull out of the polynomial x plus 2. I also want to pull out of that polynomial an x minus 1. So that when I'm done, I'm left with the smallest thing that's left. What's the smallest thing that's left here? 2x minus 1 is what's the smallest thing left. Do you see that? Now that's letter A. Letter B says find the remaining factors. Well, we're going to find the remaining factors by taking this and saying that that's 2x minus 1 is equal to 0. So that means that I'm going to have x is equal to 1/2. So my remaining factor, I would take this both ways. Are you listening? Sometimes the back of the book is going to say your answers may vary, and this is why. 2x minus 1 is also known as x minus 1/2. Aren't they the same? Okay? So it doesn't matter whether your brain accepts it to be 2x minus 1 or if your brain accepts it to be x minus 1/2. You're both right. So this is the remaining factor, either or. Okay? Do we understand that? Either or. Yes? Letter C says use your results to write the complete factorization. Use your results to write the complete factorization. Well, the first factor that they gave us was x plus 2, correct? What was the second factor they gave us? And what did we find to be our third factor? 2x minus 1 was our third factor. So this is one factorization, or if you don't like that 2x minus 1, could you write it as x minus 1/2? I would accept either one of those. That's the complete factorization. Do we understand that? And then letter D lists all the real roots. So my real roots is going to be, if I take this x plus 2 equal to 0, what's that going to be? -2. What's the next one?
1.
+1. And the last one? 1/2. There are my 3 real roots. Do we understand that? And then lastly, it says confirm your results by using the graph utility to graph the function. Could I graph this thing? Absolutely. So if I pull that up, is this a function of it? I think it is. 2x cubed plus x squared minus 5x plus 2, is that it? Yes. Okay. Do we see that here are my 3 roots right there? Am I confirming them? Are they correct graphically and algebraically? Absolutely. Do we understand that now? Yes or no?
Yes.
Okay. Do we all understand what they want you to do for those sections of your homework? And that is 39, I'm sorry, through 44. We good? Excellent. Moving right along then. The next section of homework says, use the rational zeros test to list all possible rational zeros of f. Use the graph utility to verify that the zeros of f are contained in that list. Okay, so here we go on 47. 2x to the 4th minus 17x cubed plus 35x squared plus 9x minus 45. It's telling you it wants you to do your p divided by your q. What did we learn p was yesterday? P is your constant, which is going to be the 45. And q is what?
The
Leading coefficient, which is your 2. So therefore, I want every factor of 45. So that's 1 and 45. It's not divisible by 2. 3 and 15. Not divisible by 4. 5 and 9. Bring down the 15 to the 45. What are all the factors of 2? 1 and 2. So now I need to write my complete list of all my possible rational roots. So remember how we did this yesterday? I took every numerator and divided by the number 1. So that gives me 1, 3, 5, 9, 15, and 45. Agree? Yes or no? Okay, now, I want to take every one of these and divide it by what? By 2. So 1/2, 3 halves, 5 halves, 9 halves, 15 halves, and 45 halves. Do you understand that? If any of those were reducible, let's say 16 divided by 2, should you reduce it?
Yes.
Yes. And what if they're duplicates? Should you write the duplicates down twice? No, you do not need to repeat them. Okay, now why is the P over Q values important again?
The windows.
Because isn't it nice to know your P over Q values, how many roots you possibly have that are real roots, that you don't have to use the quadratic formula for, okay? Quadratic formula is used for imaginary roots and for irrational roots, such as the square root of 5, if you understand that. Okay, they're decimals you don't like and you don't know. The non-repeating and the non-terminating ones, you with me? Those ugly ones. So my window here, remember I told you to take the biggest number. What's my biggest number? So that's going to be positive 45 and negative 45, but you're going to go 1 unit in both directions to give you what? Negative 46 to positive 46. Why is that window important again? Because it told you to confirm these graphically. So how do I confirm this graphically? Is I'm going to go back to my graphing calculator. And can somebody read that graph off to me, please? 2.
2x to the fourth minus 17x to the third plus 35x squared plus 9x.
Oh, whoa. I'm fast, not that fast. Plus 35x squared.
Plus 9x minus 45.
Okay, this is what it gives me. Now, folks, how many zeros am I supposed to have? The highest degree gives me 4. So if I change my window size to be negative 46 to positive 46 and go by units of 5, and I always change this to be negative 5 to 5 and go by units of 1. It's just easier for me to see it. That's what I have. Are all my zeros in that range? They are. Did I need to do that range to begin with? No, I didn't need to, because if I Control Z and change that, can I see all 4 of my zeros right there? Yes. Now what it's asking you to do is to confirm that your zeros are on that rational list. So look at this, and you're going to say that this 0 is right here. It looks like it's at what number? The first one looks like it's going to be at negative 1. So go ahead and do menu. You can do this 2 ways. You can do evaluation, or you can do analyze graph. So if we do this menu, analyze graph 0, left bound, right bound, there it is. The next one, left bound, right bound, gives me negative 1.5. You see that? Was positive 1.5 on my list? Yeah, it was 3 over 2, correct? Over here, there's 3. And the last one was 5. Do you see you have them all there, yes or no? We good? Okay. Going back. That's 45 through 48. Any questions over that? Okay, go to the next section. 49 through 52. Find all real solutions of the polynomial equation. Find all real solutions of the polynomial equation. Now, you know me by now. I am not going to accept all calculator work, am I? I need algebra. I need work behind it, okay? Anybody can get the answers. You can look it up in the back of the book. You can cheat on the internet. You can find it any way you possibly want. True statement. But you need to show me how and why, okay? So what we need to do first of all is we need to look at this thing and we need to say, all right, what if I graph this? This isn't graphing our greatest tool that we have. Graphing is our greatest tool. So what we're going to do is we're going to go right over here and we're going to graph this thing first. So if we graph number 50, is that 50? Anybody tell me? We're good. Perfect. All right. If that is going to be 50, okay, here are my 2 possible zeros. Do we see that? Okay. We didn't do the rational zeros test, did we? If we did the rational zeros test, then we'd know right now if we found all of our zeros, correct? Okay. What we do know is we can use the leading coefficient test. The leading coefficient tells us if the arms are going to be both up or if the arms are going to be both down, remember? Leading coefficient of 1x to the 4th is a 1, which means it has to look like the x squared, which means it's either going to go up or it's going to go down. What's it going to go? It's going to go up in this case. So we know that this thing is rising all the way up, but we also know down here it eventually is going to come into a U of some kind. Do you see that W? Do you see the W there? Do you see how it came? Do you see that? And it's really far down there, so I'm not going to worry about it here now. But I just want to show you that that's what we're going to have there. Now, with that said, that means, do I have any other zeros in place? No, I see that it's a W, right? So because of my knowledge of the leading coefficient test, I don't have to expand my window. But if I did do my rational roots, which is my P over Q, I'd be able to tell immediately that I'm done by expanding my window, correct? Okay, so here's my two values. I get these two values off of the graph. -5 and 6 are my zeros. Everybody agree with me on that? How do I prove algebraically that those are indeed factors of this polynomial? Synthetic division, how again? How would that prove it? Because your remainder should be 0. So what we're going to do is we're going to go ahead and do that now. So we're going to do synthetic division at -5 and also where? 6. Do you see how I'm putting both of those boxes there? Because I know I need to do synthetic division at both of those values, correct? So I drop down 1, -1, -29, -1, and -30. So that's going to be 1, this is -5, that gives me -6, that gives me a +30, a +1, gives me a -5, gives me a -6, gives me a +30, gives me a 0. Did I prove that those are zeros? Now what? Now I need to do it again. What degree is this going to be? No. Degree 3. So now off of what I just did synthetic division, I'm going to do synthetic division again. Drop down to 1. 1 times 6 is 6. This gives me a 0. 6 times 0 is 0. That gives me a 1. Times 6, this gives me a 0. So did I prove that both of those are factors? Yes. Now what degree is this? That's degree 2, correct? Yes? All right, now, what I'm left with is x squared plus 1 is equal to 0. What type of roots do those have to have now? The type of roots that you can have are rational, irrational, and imaginary, correct? So if I solve this, I'm going to have x squared is equal to -1. How do I get rid of the squared? Square root it. So x is equal to plus or minus what? What's the square root of -1? I. So that gives me plus or minus I. Now, is that a real 0? No. So what are my only real zeros? X equals -5 and +6 are my only real roots. I got that graphically, I proved it algebraically, and I also proved what my other two remaining roots were, that they were imaginary, correct? Do we understand that? Are we good on that, yes or no? Yep. Positive I, negative I. Okay, 58. The next set of instructions say, use Descartes' rule of signs to determine the number of possible positive and negative real zeros. So how do I do this? What I'm going to do here is I need to do my positive roots. Positive roots means you're going to count the sign changes where?
Oh, if I get to negative.
You count the sign changes in your original function. So a positive to a positive, no sign change. Positive to negative, 1 sign change. Negative to positive, 2 sign changes. Positive to negative, 3 sign changes. Remember that? Then you're going to do n minus 2 until you get to where? You cannot go negative, right? Do we all understand that? So I'm going to have 3 positive roots, or what's 3 minus 1? Or 3 minus 2 is going to be 1. 1 minus 2 gives you a -1. Can I do that? No. So I have to have 3 or 1 positive root. Do we understand that? We good on that? The negative roots. How do I calculate my negative roots? What do I count the sign changes in? f at negative x. Now which powers change? The odd powers change. So 3x to the fourth stays. 5x cubed changes to minus 5x cubed. Negative 6x squared stays. Positive 8x changes to minus 8x. And then the constant always just comes down. So count your sign changes. Positive to negative, there's 1. Negative to negative, no. Negative to negative, no. Negative to negative, no. So what does that mean? How many negative roots am I going to have?
1.
I have to have 1. Can I have any other possibilities? No. So remember yesterday, what did I tell you was the important part here? I want your positive roots, I want your negative roots, I want the number of imaginary roots you're going to have, and then I want your total number of roots you're going to have. So, my possible positive are 3 or 1. Does everybody agree with me? I have to have 3 roots, or I have to have 1 positive root. Do we get that? In addition to that, I have to have 1 negative root every time. Correct? How many total roots am I going to have? 4. So my total is going to be 4 for both of these. So how many is left to be imaginary on my first possibility? 0. And how many are left to be imaginary on my second? 2. Now, what you can do, this helps you out tremendously, doesn't it? Can't you narrow down your P over Q list if you only have 3 positive roots? You don't even have to think about any of the negatives, right? Do we understand how to do 58 through 66? Or 58 through 60, sorry. Nope, it just says use Descartes' rule of signs to determine the possible number of positive and negative real roots. That's it. This is what I'm looking for, guys. That chart. That chart is important to me. That chart is exactly what the test looks like. Do we understand that? Okay, moving right along for 61 through 65. These are the ones where you're going to have a lot going on with them, okay? So, 62. It says use Descartes' rule of signs to determine the number of positive and negative roots. So step 1, that's what we're going to do first. Letter A, I need to do my positive roots. Positive roots tells me what? Let's count the sign changes. Negative to positive is 1. Positive to negative is 2. Negative to positive is 3. Do we see that? So how many positive roots am I going to have?
3 or 1.
3 or 1. Does everybody understand where the 1's coming from? Everybody good on it? Okay. Negative roots. My negative roots, I'm going to do f at negative x. So which powers change?
The odd.
The odd powers change to give me 3x cubed plus 20x squared plus 36x plus 16. Do I have any sign changes going on there?
No.
No, so how many negative roots am I going to have?
0.
0 negative roots. So what's the important thing that I want you to write down on here?
The table.
Positive roots, negative roots, imaginary roots, and then your total. So how many positive do I have? 3 or 1. How many negative? 0. I have to have a total of 4. Nope, I have to have a total of 3, sorry. So how many imaginary am I going to have on the first case?
0.
How many imaginary am I going to have on the second case?
2.
Does everybody understand that now?
So where that top equals, the bottom has to equal to it.
Yep. Okay, letter B. Letter B says, list the possible rational zeros of f. List the possible rational zeros of f. So what's that asking me to do?
Q.
It's asking me to do P over Q. So P is going to be 16, Q is going to be positive 3. It doesn't matter because we're going to put the plus or minus there anyway, correct? So all the factors of 16 are going to be 1, 2, 4, 8, and 16. All the factors of 3 are going to be 1 and 3. So what is my P over Q values completely? 1, 2, 4, 8, 16. Because I divided by 1 then. Can you see that? Now I have to divide them all by 3. So that's going to give me 1/3, 2/3, 4/3, 8/3, 16/3. What's my window range? so that I know I can't have any more of these.
16, negative 16, so it'll be 17, negative 17.
Very good. We all good on that? Now, letter C says, use a graph utility to graph F so that some of the possible zeros in parts A and B can be disregarded. So I need to graph this, don't I? So if I come over here and I graph this, this is my function right here. What does this tell me? Think about your Descartes. Descartes said you had to have 3 positive or 1 positive, correct? Well, what do you notice here?
3 positives.
They're all 3 positives. So if I go back over here, that tells me that my only possible answers that I'm going to have is this right here. Do we understand that? It cannot be the 1, 0, 2, and 3. It's not possible. That tells me I have no imaginary roots. Do we see that? That also tells me that the ones that I can eliminate out of my P over Q is there are no negative roots. Do we see that? There are no negative roots.
Is it because you, like, since eyes are plus or minus that way, the root or why?
There's no imaginary roots because we can physically see, whenever we graph this, see 3 roots there. Do you understand that? If they're imaginary, we wouldn't see it cross the x-axis, would we? Does that make sense? Okay, there.
So when we do the window range calculator, instead of putting negative 17, so it's not negative now, if we put 0, 17.
You could absolutely put 0 to 17. And actually, do I even need to change my window range?
No.
No, why don't I need to change my window range? Because Descartes tells me that I can only have 3 or 1 positive roots. If I can see in my standard window all 3 of my roots, do I need to change my window size?
No.
No, because that is eliminating all of my P over Q values that are outside of my window range already. Does that make sense? Everybody with me on that? That's a huge thing to understand. That's why Descartes and P over Q are so helpful to factoring your problems. Do we get that? Okay? Now, do we all understand where these level middle values came from? What's 0.667?
Going for the positive 1, because there's 0 back there.
It's 2/3. 2/3 in my list of my P over Q values?
Yeah.
Yes. Is 2 in my list of my P over Q values?
Yeah.
It's 4 in my list of my P over Q values.
Yeah.
Yes. So what you're telling me is my 3 zeros that I have located, according to number of letter C, what they're asking for, is my root 1 is going to be 2/3. Root 2 is going to be 2, and then root 3 is going to be 4. Do we see that? They're asking you, off of your graphing calculator, to find the roots that you see there. And are those roots in your list? Yes, they are. So letter D says determine all the real zeros of F. Well, we just did that, right? So if I wanted the complete factorization of this, my complete factorization would be x minus 2/3 times x minus 2 times x minus 4 is all equal to 0. So what you've essentially done is you factored negative 3x cubed plus 20x squared minus 36x plus 16 into x minus 2/3 times x minus 2 times x minus 4. Do we understand that? Okay, that's your homework for tonight. Any questions? Excellent.
Could you repeat what all problems are?
Tonight's homework. Chapter 2-3, written A problems 39 to 65 odd. That's your homework tonight. I don't know what page number it is, just look for it.
Alright, yeah.
Oh, they said page 124.